Welcome back to What Starts Here. I'm Alex Loeb. Each semester on the 40 acres, thousands of students change their major in search of their true calling in life, but only one of those students changed their field of study and discovered something truly out of this world.
Discovering a planet is very exciting.
It's an amazing feeling to be able to look at something and think to yourself, I'm the only person in the world out of 7 billion people who knows that this world exists.
By the mid-1800s, astronomers had identified the 8 planets that make up our solar system. But it wasn't until 1992, 150 years later, that the first exoplanet, a planet outside of our solar system, was discovered. In 2019, Dattilo discovered 2 exoplanets.
I don't know that there was one single moment of, oh my God, I did it. I got results back and I sent a few to Andrew saying, I think these might be planets. Andrew sent me an email back that said, congrats, you found your first planet.
Finding a planet is a massive achievement for any astronomer, but Anne's discovery almost didn't happen.
In high school, I thought I wanted to be an engineer, and when I got into college, I entered as a physics major, and I thought I probably wanted to do something like particle physics, work at CERN, but then I did research in astronomy. I started out taking a class on planets, and one week, different people came in and gave talks about their research. One of those talks was by Dr. Andrew Vanderberg, and he discussed his work with the Kepler Space Telescope and its second mission, K2.
3, 2, 1, 0, and liftoff of the Delta II rocket with Kepler.
Kepler is a telescope put into space by NASA. Its goal was to find Earth-like planets around sun-like stars.
We have 42 cameras on there, and they're just continuously monitoring an area about 15 times the diameter of the full moon.
Kepler uses the transit method to find planets. When you record the light you receive from stars over multiple years, you can see various changes in the light. So when we see one dip in the light that we receive from a star, we can say, oh, something passed in front of that star. When you see that multiple times in some periodic fashion, that's a sign that there could be a planet there orbiting in a periodic motion.
To detect planetary transits, astronomers need to observe the same stars for multiple years at a time. To stay locked onto the same field of stars, Kepler needed 3 working gyroscopes called reaction wheels. When 2 of Kepler's 4 reaction wheels failed, the spacecraft began to drift.
When the second reaction wheel failed, we were all pretty bummed. We thought that was the end for Kepler.
So we talked to the engineers at Ball Aerospace who built the spacecraft.
They were able to figure out a way to nudge it back into place every time it drifted a little bit too far away using thrusters. They figured out that if you did this every 6 hours or so, you could actually keep Kepler pointed at some parts of the sky for up to 80 days at a time. And that's enough time to find planets.
And so this became what we called the K2 mission.
K2 data can give you a better insight into a wide variety of planet populations.
One of the things that I had started doing was working with a scientist at Google, and we came up with a system where we could replace a lot of the human inspection that goes into finding planets with computers.
When it first launched, human astronomers would have to go through Kepler data by hand, searching for the dips in starlight caused by planets. Andrew helped to develop a form of artificial intelligence called a neural network that could be trained to identify planets in Kepler data quickly. Modeled on the brain's ability to recognize patterns, a neural network can rewrite itself and learn how to analyze massive amounts of complex data.
We were successful in getting it to work on data from the original Kepler mission, but I wanted to know, could we also get it to work on data from K2, which is different from Kepler because it's no longer stable, it's moving around, and there are more glitches and anomalies. And that was what I suggested that Anne work on for her project.
I gave my neural network over 20,000 signals of planets and not planets, and I labeled them. This is a planet, this isn't a planet. And over time, the neural network can learn those results that I gave it. This is a planet, this isn't a planet.
But the team encountered a problem. The neural network was acing the test Anne gave it, but still wasn't finding planets in the new K2 data.
Anne is very persistent. When she hits a problem, she pushes through it, and that's something that's incredibly important for solving problems that no one else on the planet has solved before. And what she eventually found out was that the problem with the neural network was a lot of work that I had done, which involved by eye going through 30,000 signals and saying planet, not planet.
Anne re-examined the planet data that she and Andrew had used to train the neural network and corrected the answers on the test to improve the network's performance.
Based on Anne realizing this, we changed the labels. And once we did that, everything started to work really well.
After months of work, Anne's improved neural network was able to analyze thousands of transit signals in seconds.
My planets, they have identifiers put on them by NASA, so they are K2 293b and K2 294b. I think visiting the planets that I discovered would be a very painful experience. They're nothing like the Earth at all. The temperatures on these planets are over 2,000 degrees and 900 degrees. Much, much hotter than your oven, so we would definitely burn.
What Anne has done, using new techniques, applying it to the data that we had and finding planets, I just love this because this gives undergraduates the ability to share this excitement of discovering new worlds.
I would love to imagine other astronomers on a planet very, very far away, looking at our sun, looking for a signal just like us, the Earth.
Coming up on What Starts Here, we come back down to Earth and dive headfirst into UT's work to preserve the Lone Star State's most precious resource.